Hi everybody, welcome back. This is Unit 3, Nuclear Chemistry, and this will be Lesson 5. And in today's lesson we're going to talk about half-life, what half-life is, and how we can perform calculations involving half-life. You have a basis for this because you did the lab already where we calculated the half-life of ammonium and pasta-ion. So you have a basis for this. I just have a little animation here to show you. Okay. So what we're going to have is we're going to have a sample of, they say, 10,000 radioactive nuclei. The red nuclei are radioactive. And over time, they spew materials out of their nucleus and they turn into stable nuclei. And the stable nuclei will be orange. Okay? Half-life is the time it takes for half of them to decay. So if we start with 10,000, half-life is the time it takes to get to 5,000. So if you read off the curve, the half-life of this isotope is 2 days. There's only 5,000 radioactive nuclei left. Those are the red ones, not the orangey yellow color, okay, the darker color in here. So if I allow this to keep decaying, after another 2 days, you can see we have half of our 5,000 left. We only have 2,500. And if we go another 2 days, then we only have 1,500, right? Or whatever half of 2,500 was. So we'll have, I guess that's 1,275. We'll have that left. And if you keep going, you can see that every 2 days, the amount of your radioactive substance gets cut in half. So this is a decay curve for a given substance. Okay? So half-life officially is defined as the amount of time it takes for 1/2 of a radioactive sample to decay. I solve half-life problems using a diagram. You can solve them however you choose, but this is where the pieces go to the puzzle in the diagram. The circles are mass. So in the top circle is the original mass of your radioactive sample. You do not use the mass of the isotope here. So it's not the mass on an atom. It is the mass of your radioactive sample. So for example, if you had 50 grams of iodine 131 initially, the 50 is what goes in there, not this. You never, ever, ever use the mass of your isotope because that's the mass on a single atom, and you always have way more than a single atom. What goes in the bottom circle then is your ending mass of your radioactive sample. And again, that should be less, right? Because it's going to decay. And those radioactive nuclei are going to turn into somebody else. So this is the ending mass of your radioactive sample, okay? That will always be less than the beginning mass, always. This arrow represents the time that has passed in your original and your end. So we call this the time passed, or sometimes it's called the elapsed time. How much time has gone by between our start and end? 20 days, 30 days, 14 hours, it's the time that's gone by. In the denominator here, then you'll put the half-life. If 8 days have gone by and our half-life is 2 days, then 4 half-lives occurred. So the actual half-life goes under here. That way you can divide those to get how many half-life have occurred. Many half-lives of radioactive isotopes are given on reference table N. Okay? And it doesn't matter what unit your time or your half-life are in, if they're in seconds, hours, minutes, days, years, as long as they're in the same unit. So these need to be in the same unit of time. If you have a half-life of minutes and I tell you 1 hour goes by, then you should convert the hour to minutes, 60 minutes. Not really a big deal. You'll divide those. If the half-life is 2 days and 8 days passed, then that means 4 half-lives have occurred. So once you divide those, that's why they're in a numerator denominator here, you'll get some number, and that number goes in the box. That is your number of half-lives that occurred. Sometimes that is called half-life periods. So that is how many times our mass got cut in half. Okay, so let's try a sample problem, and I'll walk you through this. It's pretty simple, but they ask a bunch of different questions a bunch of different ways. So I always draw my picture and fill in what I can. What mass of iodine 131 remains 32 days after a 100-gram sample of this isotope is obtained? Just like any question with numbers, we stop, we identify what the number is, and we will put it in the proper place in our diagram. So this number, this iodine 131 here, is just the mass of the isotope. We will use it to look up the half-life on table N. Okay? So that's what we'll actually use that for. The next number you see is 32 days. 32 days, it's a time, so it's going to go either in my numerator or my denominator. If it is the time that has gone by, it goes on top. If it's the half-life of the isotope, it goes on bottom. So what mass remains 32 days after a sample is obtained? That is the time that is passed. That goes in the numerator, 32 days. 100 grams is another number. That's the original mass of my sample. That goes up top. So what I'll do then is I'll go to table N, and we will find the half-life of that isotope from table N. If I could find my reference tables, that is. Okay. So here's that reference table, table N, sorry for the delay. And if we look up our isotope right here, we had iodine 131. You will see the half-life of iodine 131 in this table. So it's 8.021 days. So we go back to our notes and we fill in the half-life that we got from table N, 8.021, I think that's what it was, days. Let me check one more time just to be sure. 8.021. Okay, so if you know what's in the numerator, every 32 days have gone by, and you know how often the mass gets cut in half, which is about every 8 days, you can divide those. So every 8 days our mass has been cut in half, and 32 days have passed. So if you divide those, you get about, and you want to round this to the nearest whole number, you get about 4. So this should be rounded, but it should be close. So 4 half-lives have occurred, which means now I cut this 100 in half 4 times. So I divide by 2 once, and you get 50. I divide by 2 twice, and you get 25. I divide by 2 3 times, and you get 12.5. I divide by 2 4 times, and I get 6.25 grams. So since 4 half-lives have occurred, I cut my mass in half 4 times. 1, 2, 3, 4. And that is my final answer. This is the mass of my radioactive isotope that remains. Okay, let's do another practice here. What total mass of a 16-gram sample of cobalt-60 will remain changed after 15.9 years? So, first number I see is 16 grams. That's my original mass of my cobalt-60. Will remain unchanged after 15.9 years. That's how much time has gone by. It's cobalt-60, so I will look that up in table N and get the half-life of cobalt-60. Cobalt-60's half-life is 5.271 years. So every 5 years or so, the mass of radioactive cobalt is cut in half. 15.9 years have gone by. So how many half-lives have occurred? That's what we're going to figure out by dividing those. 15.9 divided by 5.271, and you get 3. About 3 half-lives have occurred. So we have to cut the original mass in half 3 times. Divide by 2 once, you get 8. Twice, you get 4. 3 times, you get 2 grams. So 2 grams of our radioactive isotope remain. The rest of it has turned into a new element. After 3 half-life periods, 12.5 grams of an original sample remains unchanged. What was the mass of the original sample? Different question. They did not tell us how much time passed, and they did not give us the identity of the isotope, so we can't look up the half-life. But we don't need to, because they told us 3 half-life periods have occurred. That means the mass was cut in half 3 times. 12.5 grams of an original sample remains unchanged. 12.5 grams is what's left. Can't pause it. Sorry about that. Welcome back. That period's over, and now we're back just to wrap up this problem. So they've given us the number of half-life periods. They tell us the remaining mass of our radioactive isotope. So we know that since the original mass, 3 half-lives have occurred. So we need to go back up this time. Well, if you remember, when you go down, every time you go down, you divide by 2, right? So if we're going up, we don't divide by 2, we multiply by 2. And we're going to multiply by 2 3 times. So 12.5 times 2 gives you 25, times 2 gives you 50, times 2 gives you 100. So my original mass was 100 grams. Tomorrow in class we'll be doing some more with the half-life problems. So what I'd like you to do for tomorrow is, if you could, fill in the information on this example number 4, what numbers go where, maybe try to solve it. And in the meantime, we'll do more practice with this in class. Have a great night, everybody. Bye-bye.